Okay, let's do the bottom of page 79. You're going to do this with me, and we're just going to talk through some of these. We're not going to do them all, and then you're going to go do some by yourself later, okay? So looking at number 11, and you see that on one side of the problem, we have 2 plus 3 plus 4. 2 plus 3 is 5, right? So the missing number over here would have to be 5. There's really no other way we can do that. It's just showing that. You put those together and you got 5. On this next one, on number 12, what plus 25 equals 25? That one would have to be 0, wouldn't it? Because remember, the property of 0 is doesn't change anything, right? Okay, look at number 13. We have 125 plus 262 equals what? Plus 125. Well, this is showing us the commutative property because you're just going to do the turnaround fact. So, guys, we do that when we're doing fact families. 3 plus 5 equals 5 plus 3. So it doesn't matter how big your numbers are. You're going to do the same skill. Okay, look at number 14. Number 14 has 170 plus 30 plus what equals 300 plus 170 or plus 150. So when I put this together, that is the 300. So what I'm missing over here is the 150. Okay, let's do a couple more. So down here, let's look at 17. 17, look at this side, 23 plus 11. This side has 23 plus 11. So the only thing I could possibly be missing is a 0 because I've already got a 23 and 11. Kind of see how this is working? All right, let's go down to number 20. 12 plus 2 plus 20. So 12 plus 2, that's 14. I have 20 over here. So I would put 14 right here. Basically, you're trying to get the same amount on both sides, but remember, numbers are flexible. Like we did in our small group, I could take 5 and 0, or I could take 4 and 1, or I could take 3 and 2. So I've got to be able to pull those numbers apart and put them back together where it makes it easiest for me for them to work with, or easiest for me to work with them. That's how you say that. Sorry. Okay, so let's go on down and let's look at number 25. Barry said the sum of 3 plus 6 plus 5 is the same as 6 plus 5 plus 3. Don said the sums are different. Who is correct? Well, a sum, remember, that is your answer to an addition problem. Don't forget, that's our vocabulary we talked about this morning. First thing in our warm-up. So looking at this, we do have all the same digits. They're really grouped the same. They're just in a different order. So that is going to be the same answer because 6 plus 5 is 11 plus 3 would be 14. That is the same no matter which side what you do first or what order it's in. So, who's correct? Well, it has to be Barry because Barry says they are the same, and he means they're equal when he says that. So, Barry is correct. And in this case, they're grouped the same. They're just in a different order. So, technically, it's the commutative property. But Barry is correct because the numbers being added are the same. They're just in a different order. So if the numbers are the same and you add them in different order, it doesn't matter in addition. Okay, number 26. Below is an example of a property of addition. Both sides of the sentence equal 22. What's the missing number for each? So they're telling us that when we put these together, we're going to get 22. I like to think of them like a number bond. So 8 plus what number is 22? Was it 8 plus 14? Let's see. Is it 8 plus 14? Well, if I have 14, I need 6 more to make 20, so I think that is correct. 8 plus 4, you can do it like this. 8 plus 4 is 12. Carry my 1, that is 22. Okay, so this is 14. That would work on both sides of that. 30, way too much. That'd be 38. So I just have to think what makes that statement true. And then do some math. This is my proof. I need to prove my thinking. I don't just circle answer A. Circling this answer is not math. This over here, this is math. So you have to show your thinking.